We're getting close to finishing up this chapter. We've dealt a lot with exponents. We dealt with multiplying, so we talked about distribution and then multiplying two binomials. Some of you do this with another form of distribution. Some of you guys have been using the box. That's great. We're going to come back to that on Thursday when we get to 3.1a. But for today, we want to go back to graphing lines. So today is the 3rd. And our goal for today is we're going to be looking at two different forms of linear equations. A linear equation is just an equation that makes a line. You guys already know one of these forms. You already know the one called slope-intercept form. And we know how to graph in slope-intercept form. I want to make sure that we can also graph if we're given an equation in what's called standard form. That'll probably be the new thing for some of you. So let's have a look at that warm-up that you guys were working on at the beginning of the period. All right, so reviewing slope-intercept form. This is called slope-intercept form because it's got the slope and the y-intercept in it, right? You guys are used to writing these types of equations or looking at these equations and knowing where the slope is and the y-intercept is. So we're going to be looking today at equations that look like this, and our goal is going to be to convert them into slope-intercept form so that we can graph it. Let's make sure that we remember how to graph slope-intercept form first, though, because it's been a little while. So I'm hopeful that you were able to look at this equation and tell me that the y-intercept was at 4. Is that what you guys had for your y-intercept? If I wanted to be more technical, I could write that as 0, 4. But either way, that tells us that this graph is going to be crossing our y-axis at 4. And the slope is going to be -2/3. That's a negative slope. Can you guys check your work and make sure that you drew a slope that was going downhill from left to right? We should have been going down 2/3. So if I start counting, down 2/3, down 2/3, and then back it up, we get that line. How'd you guys do on that? Are we still experts with graphing lines? If you had your slope going in the wrong direction, that's okay, just fix it. Remember your little slope guy. If he stands on the left and it's a negative slope, you should be looking downhill. All right, second one here, we had a y-intercept at 0, -2, and a slope of 3. Some people like to write slope as a fraction. We can always put 1 underneath a whole number like that. And that's a positive slope, so we should be going uphill, up 3 and over 1. So y-intercept at -2, counting up 3 and over 1. And there we go. How'd you guys do? Are we slope-intercept form experts? That's great. So then all we need to do, if we can do this, then the big goal for today is if I end up with an equation that doesn't look like that, if I can turn that into slope-intercept form, then I can graph this. Okay, this is the equation of a line. Our goal for today is to take something that looks like this and turn it into this. And that's it. Okay, so down at the bottom of the page, you'll see two equations. These are equations that are in a form called standard form. Standard form has the x's and the y's on the same side of the equation. There's never a fraction in standard form. We always have integer values. And in standard form, you can't look at the graph, or you can't look at the equation and know anything about your slope and your y-intercept. Okay, so when I look at this, the 6 is not the slope, because it's not in slope-intercept form. And the 12 is not the y-intercept. So to find those two things in order to graph this, we need to do some work to get it into slope-intercept form. And the key to that is right here. We just got to get y by itself. In slope-intercept form, just going to scroll up here, In slope-intercept form, it's always an equation that says y equals. Y is by itself over here. So if we can force this equation to look like that, then we will know that our slope and our y-intercept. So let's do this. I'm looking at this side of the equation. Let me go ahead and draw my barrier here to separate my two sides of the equation. I'm looking over here where the y is and thinking, I need to get rid of some stuff over here. If I want y by itself, some stuff's got to go away over here. Focus on this positive 6x. What can I do to make a positive 6x go away? Any ideas? What do you think? We could do minus 6x, right? That would cancel it completely. That would cancel both the 6 and the x, right? So let's do it. We're going to go minus 6x underneath here. But those rules of algebra say if I do that on this side of the line, I got to do the same thing over here, right? Now, is the 6x going to go underneath the 12? Is that a like term? So I'm just going to kind of put it off to the side here, minus 6x, because it doesn't combine with the 12. The 12 doesn't have an x. All right, so that canceled. That's wonderful. Check it out. Now we just have a 3y over here. It's not quite by itself, but it's close. And then an equal sign. And then I want you guys to check out what I'm doing here and see if you understand what's going on. Do you see where that minus 6x and that plus 12 came from? Why do you suppose I put the minus 6x first and the 12 at the end? Anybody know why I did that? Just because I'm feeling weird today? Why do you think? No idea? Well, we're trying to get it to look like this, right? And usually the x comes first. That's why I put the x first. Okay, if you wrote yours as 12 minus 6x, that's fine. Same thing. All right, one more step. I almost have y by itself. Right now I got this pesky 3 that's multiplying by a y. What's the opposite of multiplying by a 3? Yeah, let's divide. Now when we divide in an equation, when I divide, I have to divide everything in the equation. Every term has to be divided by the same thing. So we're dividing all that stuff by 3. These 3's are going to cancel. That's just y now. That's what we wanted. And then we got to do some division over here. Negative 6 divided by 3 is negative 2. And 12 divided by 3 is 4. And that's it. All right, so this is slope-intercept form. I'm going to copy it underneath here. Y equals negative 2x plus 4. We started off with standard form, which was 6x plus 3y equals 12. And we did that conversion to get it into slope-intercept form. What do you think? Just a couple steps of algebra. So the whole goal is to get the y by itself. We started by getting rid of the 6x, did minus 6x on both sides. We almost had y by itself. To get rid of that 3 that was multiplying, we divided everything by 3, and that got us our equation. Now, can you guys look at this equation and tell me what the slope is? What's the slope? Negative 2, and the y-intercept is 4. And if you needed to graph it, do you feel like you could graph that? Of course you can. All right, let's do another one. Getting y by itself. So just like before, let's focus on the side with the y and see what we can get rid of. Usually we want to get rid of the x's first. We got a 2x over here. How can I make a positive 2x go away? Well, minus 2x on both sides. We've still got a negative 5y equals. This time around, I'm not going to put the x's first. Sometimes, some people do, some people don't. We'll look at it both ways, and I'll let you guys decide which one works better for you. We have one more thing we need to do. We got to get rid of that negative 5. That negative 5 is multiplying by the y. How do I get rid of multiplication by negative 5? Divide by negative 5. And when we divide, make sure that you're dividing everything in your equation. Those ones cancel. Y equals 10 divided by negative 5 is, it's going to be negative. 10 divided by 5 is 2. And 2 doesn't divide by negative 5 without a decimal, so we'll leave that as a fraction. My question to you is this fraction going to end up positive or negative? Right now it's a negative over a negative, which is going to turn positive, and I'm just going to write that as 2 over 5x. So technically that is in slope-intercept form. Is it bugging anybody that the x is at the end, though? It's kind of bothering me. I'm not a big fan of that. That's why when I go to this step, I usually put the x first. I kind of wish I'd put that x there first, but that's okay. We can just rearrange it when we write our final answer down. I'm just going to rearrange this and put the 2 over 5x first, and the minus 2 at the end. Now it looks more like slope-intercept form to me. The original standard form was 2x minus 5y equals 10. And there we go. All right, so the goal is to get y by itself. So flip the page over. I'm going to have you guys practice a few of these. So for right now, I'm going to have you focus on the odd numbered problems on this page. That would be 3, 5, 7, and 9. I need you to complete those today in class. I'm going to come around and go over some of these with some folks. So if you need one more example to go over with me, just get my attention early on. If you're feeling pretty good, feel free to go ahead and get started on that. When you get to number 9, I do want you to do both problems for number 9. You're gonna do both of those problems down at the bottom of the page. But you can skip 4 and 6 and 8 if you want. You could always come back and do these for some extra practice later if you want. All right. I'll put answers up on the screen here in a little while, but I want to give you guys a chance to work through. Please, please, please ask some questions today. I'll be around to assist. So I have the first 3 answers up on the screen. When you guys get down to number 9, I want to remind you of something. Can you guys see that? Yes. You cannot look at this and know what the slope and the y-intercept is. The y-intercept is not 8 here. So we need to do the same work with this. I need to get y by itself, and then I'll know what the y-intercept is.